Last week, I walked into the office of a CIO at a large railway company. Former military guy, gray hair, big beard, generally kind of an angry individual. He looked at me and he said, infrastructure for AI is kind of like riding a unicycle in a marathon. And I said, Gary, what are you talking about? And he said, we've realized that it's a very long race, but we're going to need to balance and adjust to line of business every single step of the way. I looked at him and I said, it's okay. We got you. We've got a solution for you. And that's what Nishant and I want to talk to you about today. So first of all, thank you for being here. We appreciate the opportunity. Thank you for listening. Questions, comments, it's been fun to sit in the back of the room and listen today. Keep them coming. We appreciate that. Nishant is our Senior Engineering Product Manager for our AI servers. It's a pleasure to have him with us today. We're very fortunate to do that. My name is Jason McGee. I'm part of our Office of the CTO for our computing business unit. And I think I have just an incredible job at Cisco. Get to come in and talk to customers a lot about where we're at from an AI perspective. And there's all sorts of models that are out there. We break it down. There's really 5 big areas that we're focused on. What makes Cisco unique is the ability to tie all of those layers together. At our last Tech Field Days, Siva and Tushar came in and talked about some of our solutions. But the breadth and depth of Cisco is what allows us to take advantage of the high-powered AI servers that you heard about during the keynote and the ones that we'll hear about a little later on today. Those solutions can be broken down into some big buckets. Our Cisco validated designs are where we take our best practices, our lab testing, our certifications, performance testing, and we roll that into a user consumable document. They've been around for years. We do them across the company. They're generally several hundred-page documents, but the really cool thing is we've made them as code. So they're consumable through Git repositories. Our customers are able to get those CVDs and deploy that validated configuration or blueprint based upon the knowledge base of Cisco as a whole. But we looked at that and we said, you know what, we could probably make that easier for our customers. So we took and we put a product wrapper around our Cisco validated designs for AI. And you may have heard this last fall, we introduced our AI pods. And what AI pods are, is they're simply a purchasable Cisco validated design, including the networking, the computing components, the software components, all those layers that we showed on the previous slide. The servers that Nishant and I are going to talk about today are what powers AI pods using the information from our CVDs. And if you want that available as a service, like Dan just talked about, we have Hyperfabric. And so that's that glue. That's the solutions that pulls AI together for us. But it all starts with the fabric, and Hyperfabric AI, that portfolio is an incredible piece of that. So we're going to spend the rest of the time that we have together, half an hour or so with some time for some Q&A, really focusing in on that next layer up, is what does the compute form factor look like? How do we power the computing engine that's driving the workload, that's generating all the traffic that's populating our networks? How do we get the work done? When we look across our customers, we've seen the hyperscalers, some of the large model trainers, really be focused on the large language models. When we get into enterprise customers, we're finding that your mileage is going to vary as you move across the AI landscape. Some of them are doing training, which you see on the far left here, all the way over. They're adding their own data into it through retrieval augmented generation. They're doing light tuning. They're doing retraining some of these existing models, moving out into the inferencing space. We're seeing massive growth in the inferencing space over the next several years, and we think that's going to dwarf the training space as the industry moves toward more specialized models. We're seeing the large models generate into smaller specialized models that are industry specific or use case specific. And that's what we're building the platforms for, to take advantage of where the world is going from that AI continuum. If you look at the compute portfolio that we've been selling for over 15 years, a phenomenal amount of capabilities in the AI space. But it really fits in to that inferencing, light training, tuning part of the model. And as a quick glimpse, if you look at what's there, If you map the GPUs to the server platforms that we have available today, there's a lot there. Don't try to consume it, but the takeaway is that we can handle, we think about 60% of the AI workloads that are running in enterprise today with the GPUs that are in our blade servers and our rack mount servers. Quick refresher, we call our current modular or blade-based systems X series. We have a rack mount line of servers that we call C series, just so that I know as you move across the Cisco landscape, we've got all sorts of nomenclature and landscape. But the X series are the blades, and that's what you see on the left-hand side. The existing kind of the typical 1U, 2U rack servers are what you see on the right-hand side, with a variety of GPUs from different vendors that are available in them. What we're going to be talking about the rest of the day is going to fall into that right-hand side, and it's going to fill out some of that continuum that we looked at earlier. We heard loud and clear from our customers, from our partners, even Cisco IT internally, one of our biggest customers, is that we needed something to fit into that training space. And so we've introduced a large training server, dense GPU server, using the high-speed fabrics for GPU to GPU communication. So if I'm running the NVIDIA GPUs inside the system, then we use the NVIDIA NVLink fabric for that fast fabric internal GPU to GPU communication. If I put in the AMD GPUs into it, then we use the Infinity fabric from AMD, and Nishan's going to show you what those architectures look like as we get into that. And then very exciting, you see with the yellow blob onto it, what G2 announced during the keynote today. What we call our C845A server is our dense GPU server, but designed for flexible workloads. A lot of our customers don't need the full 885, 8 GPUs, high-end GPUs. They're either running an HPC environment today, and they kind of want to crawl, walk, run into the AI space, or they're getting into some of the smaller language models, they're beginning to get into training, and they need something they can stepwise grow into. What we're hearing repeatedly is that in the enterprise space, a lot of the software teams are not ready to implement AI. They're gathering their data, they're cleaning their data, and getting that ready to go. And a lot of times they don't need to start with 8 GPUs. They can start with 2, they can grow to 4, 6, 8, depending on what they need. And so that's the box that we're very excited to introduce today, and we'll dig into a little bit more details around that. No matter what these servers are, if I can't operate them in a simple, easy manner, then it's kind of pointless. We're going to make life harder for the end users. And so what we've done with all the compute portfolios is we look at our traditional compute, whether that's the rack servers, whether that's the blade servers, we've managed those servers locally for years. We call that very creatively our Unified Computing System Manager. Well, all of those servers in those legacy environments take advantage of that large number of GPUs that we put up earlier. We can also take and plug those existing servers into our as-a-service management architecture and what we Call Intersight. That gives us capabilities to do some of the AI ops functionality for our servers. So we can look at proactive TAC. We can dismiss parts before the customer even knows that they fail. We can do over-the-horizon notifications for our customers, kind of help them see around the corners, whether that's a security advisory, whether that's a vulnerability, whether that's a failing hardware component in the system, using the metrics and the monitoring that we have on the back end of that system. We're collecting a little over 13,000 data points a second on that platform, an amazing amount of telemetry that we're using in the AI ops functionality to help out our customers going forward. What we're doing and we're talking about today is the AI servers that you see in the middle here will also connect those servers to the same operations platform. And the takeaway is that when we move AI into the enterprise space, the governance, the operation, the tooling, the APIs that are already being used in the enterprise space can be used for AI. I don't need a separate silo. I don't need a separate set of stack, tooling, training. I can use what I have in-house today. So the sovereignty, the governance, the best practices that our IT has put in place, we can take advantage of with that existing management operations infrastructure. So with that, we're going to dig deep into the 885 first, and then we'll jump into the newer box that was introduced during the keynote today. So Nishant, I'll turn it over to you.
All right. So I'm going to go into the details of UCS C85A M8. It's a dense GPU server which was announced and late last year. It was our newest addition to the Cisco UCS product family, and it's designed for some of the most compute-intensive and data-intensive workloads, including LLM training, fine-tuning, deep learning, and depending on the size of the model and number of concurrent users you want to support, you can actually even use it for RAG and inference kind of use cases. As I mentioned earlier, it's a dense GPU server. It can support 8 of NVIDIA's HGX, H100 or H200 GPUs, as well as AMD's MI300X GPUs. And on the CPU side, it's a dual socket server with support for AMD's 4th generation and 5th generation CPUs. Here is a bit of technical details. It's an 8RU air-cooled server and supporting, as I mentioned earlier, both 4th and 5th generation AMD EPYC CPUs. But instead of supporting the entire set of SKUs from these generations, we have picked certain SKUs of CPUs which are more optimized for AI kind of workloads. So there the focus is more on the clock rate. So basically, if you see this table here, it shows CPUs with max boost rate around 5 gigahertz, that's 4.3 gigahertz, as well as 3.75 gigahertz. So those are the CPUs optimized for AI workloads. It has 24 DDR5 DIMM slots, which can operate up to 6,000 megatransfer per second. Standard storage, mirror boot drives, 16 NVMe for local data storage, could be checkpointing or any other purpose. GPUs already mentioned, H100 and H200 from NVIDIA SXM form factor, and AMD's MI300X, which is OAM form factor. In terms of network cards, so it does have quite a few PCI slots in there. So these servers are sort of designed to be deployed in clusters. The compute fabric is extremely important for these. So we have one NIC per GPU for that east-west connection to deploy it in a cluster. And then we have up to 5 NICs, which can be used for the front-end network or the north-south connectivity. I'll go into more details on that. What we are supporting there right now is the ConnectX-7 or B3140H, the 400 gig NICs or super NICs for the east-west connectivity, and 2 by 200 gig NICs and DPUs for north-south. And then, of course, there is an OCP card, which can be used for host management. In terms of cooling, there are quite a few fans there, 12 fans up front, and there are 4 fans inside to cool the SSDs. And then power supply, it's a power-hungry server. There are 6 3-kilowatt PSUs operating in 4+2 redundancy mode for the GPUs, and there are 2 2.7 kilowatt PSUs for the CPU sled components.
I have a question regarding this, yeah? Power hungry means also the GPUs will produce more heat, I assume, yeah? I see this on the gaming computer from my kids, yeah? They are
right.
always running hot. So what do you see overall on the, let's say, cooling requirements compared to a normal server without all this GPU density? Is it double, or do you have kind of a relation how much more heat they will produce?
So when you say in comparison to a regular server, I mean, that's sort of like subjective. But these are designed to be kept in regular data centers. It's air-cooled, I mean, the amount of heat dissipation and the number of fans. It basically, you can put it in a regular data center right now. It doesn't require any special cooling.
So it is not that, let's say, magnitudes higher. It will still work where, let's say, systems without GPU have worked.
That would be correct, yes.
Okay, yeah.
Yeah, you don't need any special requirements to cool these. I mean, there are newer GPUs coming on NVIDIA and AMD's roadmap that would probably require some level of liquid cooling. So, but that's coming. That's next on the roadmap.
Okay.
And so here is an exploded view of the server and as you can see, it's a modular design. On the top left, you You can see the GPU sled, which is 4RU. Right below that is the CPU sled, and then below that a layer of PSUs. Up front, there are 12 pins, but at the bottom you can see those are the drive slots. And of course, I'll get into more details on the specifics of these components. Here's a rear view of that, and then in the middle there you can see those 8 PCIe slots for the east-west connectivity. A closer look at the rear view of the server. So as I said earlier, GPU tray on top, CPU tray in the middle, and then the PSUs. Now, taking a closer look at the GPU tray, as I mentioned earlier, it has support for 700-watt H200 SXM GPUs from NVIDIA and 750-watt MI300X GPUs from AMD. And if you look at the sort of like a logical block diagram of the GPU board here, this is for NVIDIA. You can see that there are 8 GPUs which are connected to 4 NV switches on that board through multiple NV links. What it allows is non-blocking communication, high-speed communication between any pair of GPUs here on the board, and you can achieve up to 900 gigabytes per second bidirectional bandwidth. And to provide connectivity to the outside world, when you're putting it on a cluster, these GPUs are connected to basically sort of like their own sort of like CX7s or SuperNICs via a set of PCI switches, as you can see here. So that's NVIDIA GPU board design.
Quick question.
Yeah.
Those SuperNICs, are those Bluefield 3?
These are BF3 B3140H.
Okay. So this is Spectrum X?
No, this is just the GPU board, actually.
Okay.
There is no Spectrum or any external switch on this. So up till this part, this actually sits on the GPU board, and this is part of the CPU sled. The PCI switch and whatever you see above that, that's part of the CPU sled. There is no external component. All of it is on the server itself.
Okay.
Are you getting to the InfiniBand question?
Eventually. Because, well, you knew that's where I was going.
Yeah, I mean, the Bluefield 3s and the Connect X7s support either or.
Right.
All of our reference architectures are Ethernet based. That's where we see the industry going. But recognize, we do have some customers, particularly the HPC, that have an InfiniBand fabric. So we will support InfiniBand connectivity on this. It's not our primary use case or where we see the future going, but as a transition period, it's something that is supported with this box today.
Well, I mean, I don't want to speak out of turn, but I think NVIDIA realizes that too, which is why they put so much development into Spectrum X recently, is because they realized that InfiniBand basically has a ceiling and feature complete at this point, and they're wanting to get people to migrate off of it as much as possible, because especially if you're going to start deploying this in a cloud scenario, clouds are not going to deploy InfiniBand if they don't already have it, because that's a cost that they don't want to incur.
Exactly. And we looked at a hard stance and we said, let's just make it easy and acknowledge that there's some InfiniBand or there's a lot of InfiniBand out there. So we'll support if somebody wants to connect it that way and transition over with NVIDIA and the rest of the industry. Fantastic.
Okay, thank you.
And on the next slide, I have the AMD GPU board design. So the top half, as you can see, is actually pretty similar to what you saw on the previous slide, but the bottom, that's the AMD GPU connectivity. So there are 8 OEM form factor GPUs from AMD, MI300X in the scenario, and they are all connected via this full mesh kind of network. And this basically ensures 128 gigabytes per second bisectional bandwidth. And this, of course, is based on the Infinity Fabric from AMD. Closer look at the CPU tray. Support for, as I mentioned earlier, AMD's 4th and 5th gen CPUs, and we have picked 9554 from the 4th gen and 9575F CPUs from the 5th gen of AMD CPUs. And then for certain configurations where the customer does not require as much compute power or as many cores, we also support for 9535. And then on the DIMM side, we support 3 sizes currently: 64, 96, 128 GB DIMMs, depending on what the requirements are and what GPUs they are using. They can pick appropriate DIMM. Now, looking at more of like closer look at the especially the networking components here. At one, you can see those 8 PCIe slots for the compute fabric or the backend connectivity. And as I mentioned earlier, we currently support CX7s and B3140H SuperNICs. At number 2, you can see it's a B3220 DPU from NVIDIA. We also have support for CX7 if you don't require DPU functionality or any offloading. And then, but if you want DPU, but then 400 Gbps connectivity, then there is support for B3240s also. At number 3, you can see the 2 PSUs. These are 2.7 kilowatt and 1+1 redundancy mode. These power primarily the CPU slide components as well as the drives. Number 4 is the DCSCM, which is Data Center Secure Control Module, and has basically, it houses a BMC, and then there's an RJ45 port for out-of-band management, and the mini display port, and a few USB ports for KVM connectivity.
Just one question we had before the presentation for Hypershield. So on 2, you could run then eBPF, yeah? If we have a DPU networking card, that would be supported, yeah?
Yes.
Okay, wonderful.
And that's the Super NIC, is the DPU, the branding thing.
So we have both SuperNICs and DPUs. I mean, I think NVIDIA uses the terms.
Yeah, NVIDIA prefers the term Super NIC because because AMD calls them DPUs, and then Intel calls them IPUs for some reason.
Yeah, and then finally at number 5 we have a couple of RJ45 ports. That's an Intel card, OCP card, which can be used for host management here. So quite a few ports. In terms of how it's, the network connectivity, we basically see 4 types of networks on these servers. There is, of course, management network, which is out-of-band management, as I mentioned on the previous slide. There's front-end network, which can be used to connect to the broader data center. It can be used for getting access to certain data for inferencing. Storage network, of course, to connect to the storage. And then the most critical one, I think, in this scenario would be the inter-GPU backend network, also known as compute fabric. And as you can see, like 8 NICs, which will support this. And to create a small cluster, all you basically need is one 64-port switch. In this scenario, it's Nexus 9364D GX2A. And you can create a really small cluster of just 8 servers using it. But if you want to scale it, let's say a larger cluster of 32 nodes, then of course you need a spine leaf kind of architecture. The important thing here is that all of this network has to be non-blocking, non-saturated. So basically, if you are connecting a 400 Gbps NIC, that leaf switch, connectivity to the spine switch from the leaf also has to be 400 Gbps or higher.
Do you guys support 800 gigabit NICs?
Not yet, not in this one yet. As we move to the future generations of this, we will have support for it. Power and cooling, again, it requires a lot of power to power all those GPUs and CPUs and everything. So it has 6 PSUs, primarily for the GPUs at the bottom there. You can see those are 3,000 watt 80 plus PSUs running in 4+2 redundancy mode. And let's say if 3 of them actually become inactive, then of course the server still operates, but the GPU performance will be capped at 60% across all of them.
That's 12.5 kilowatts per server?
That is the maximum possible power consumption that we expect. So that's basically primarily used for sort of like a provisioning purpose. But in normal scenarios, I don't think you will see more than 8 to 9 kilowatt.
Do you have like a recommended density that you're planning for in a rack so that you don't melt it through the floor?
It depends on basically what power supply customer has, but there is a customer that's trying to put 4 of these in one rack. So I think they have a 60 kilowatt power supply in that rack, and so they will put 4 of these, so around 48 to 50 kilowatt will be for these servers, and then there is top of the rack switch and other things in there.
Currently air cooled, correct?
It's all air cooled.
Plans to make it water cooled?
That will be a future platform.
Okay. The only reason I ask is NVIDIA Haswells are water cooled because they're hot.
Yeah.
Is the storage accessible from all the servers? So server 1 can access the storage from server 2 as well. So it's
Not the local storage, if that's the question. That's all local. But yeah, you can have a distributed storage, software-defined storage connected to these, but that's a different architecture, of course. There are.
okay. So do you do that yourself, or do you use other solutions for?
We are looking at certain partners to support it.
I can think of one.
I figured you could.
All right. So hardware configurations. So these are what we are doing here is we have created these sort of like optimized fixed configurations for these servers. So let's say if you're doing training and then you want to deploy it in a cloud-like environment, then you will have certain specific requirements. You might want B3140H as well as a B3220. But if you're doing inferencing, you might not even require those east-west NICs, right? So for different deployment scenarios, we have created these fixed configurations, which are optimized for, again, as I said, like those specific scenarios. So we have about 16 fixed configurations here using H200, and then there is for H100, fewer for H100, of course, because we have H200 now, and then for MI300, about 5 or 6 of those. And this is also used, of course, in Hyperfabric cluster for AI, as you mentioned. Again, so I think the key differentiator for the servers are these 3 things. It delivers unmatched performance. It has this high-speed GPU interconnect on the server itself, the board that has NVLink, NV switches, and scalability, those 8 NICs, which allow it to become part of a really large cluster. And that helps us deliver serve basically all these use cases, AI, starting from Gen AI training, model training, all the way to deep learning, reinforcement learning, and even some large model inferencing. HPC, quite a few of our customers actually deploying these in HPC environments. And then you can also do some real-time data processing, which is through, by accelerating through GPUs. So again, with Jason, as I mentioned earlier, not every customer requires such a powerful server. For some of them, they're just starting on their AI journey. They require fewer GPUs, smaller density. So for that, we announced C845A M8 today, and Jason will share more details on that.
Wonderful. Thanks, Nishant.
Thanks.
Appreciate the question. Anything else on the 885, the big box, before we move on? Okay. It's big. It's powerful. It will do a tremendous amount.
I'm just trying to get my head around 60 kilowatts in a single rack. Like that could
For
be
just
seen
4
in
servers.
an hazardous environment with a high voltage coming through.
Don't look up tech specs too closely, because NVIDIA can get 60 kilowatts in a half rack.
And even that, I mean,
And one of those network diagrams was 32 of those servers put together. I think, one of the big takeaways, I started with solutions, and I really want to emphasize that the validated design on how you put it together, the AI pod where I can order as one, or I think the demo for Hyperfabric is incredible, because Dan started out with, user guidance, what cable to plug into what port. If I'm paying that amount of money for those high-end GPUs, I want to maximize performance. I mentioned Gary, the CIO that I talked to last week. We had another CIO that mentioned to us, he said, my job is not to build the AI applications. It's not to transform my company. My job is to keep the GPUs as busy as possible, to fill them with data. He's like, that's where our investment's at. And I need to ensure that I'm doing that. And that's where those guided configurations, the Hyperfabric AI can come in and really benefit around that. Okay? But the conversation we're having is a lot of customers are not ready for that massive box. And we really think the 845 is going to fit a wonderful niche architecture that's out there. And I say niche, I shouldn't use that term. But being able to start with 2 GPUs, grow in increments of 2, 4, 6, 8 of that, and have a variety of GPUs. I can use the H100, the H200, kind of the top end from NVIDIA today, or I can use the L40 GPUs for that are just fine for some of the workloads that are needed out there.
When you get an outreach for something like this, does that create like a professional services engagement so that you can talk the customer through that kind of discussion? Or is this something that you're really only contracting through other partners that have experience doing this deployment?
Both. So yeah, we're doing a lot of that. When I mentioned the AI pod, that comes with the services wrapper around it. That's a piece of that.
And how much money it better?
It's kind of interesting to know, especially because of everything that's going on in Europe, and probably others will follow as well soon with ESG and everything that's going on.
Yes.
Making sure that you're going over the regulations that going on with AI.
Exactly. Yeah, and even as we get into the switches, the optic density, it's going to go beyond just the GPU, the server. Our entire data centers are being affected, and we hear it every day. But when you actually see it on paper with the specs, it's mind-boggling. What we can do, or what's out there, and the amount of work that can be done from this. With the, I'm gonna have a hard time not using the code name for this box, but the 840, since it's just brand new today, but the 845 box, it is a 2 CPU AMD EPYC based system. And like I said, it can grow in the GPUs. Where I do want to emphasize on this is that we're using the 885 we talked about before. That's an HGX reference architecture from NVIDIA. This box is the MGX reference architecture from NVIDIA. We looked at that, and there's some things with the off-the-shelf MGX specs that most of the MGX servers in the world are doing that we thought we could do better. There's some simple cable management, cable routing items that we improved that drastically reduced the amount of airflow, improved serviceability of the box. One of the things that we did was that most of the time on MGX architecture, all the power supplies are on one side of the machine. That prevents the box from passing a drop test because it goes on one side. We evenly distribute the power supplies horizontally across the bottom of the box. So if we have to do something like a drop test for reliability. Again, those things that are just standard for our enterprise compute customers that they're used to using it and have to have in that. One of the other things is that typically it takes about 38 to 40 screws to remove the GPUs from an MGX design. This box, one screw. So if I need to replace a GPU, we've made serviceability easy on it for the customer. So, really trying to bake in some of those things that our Cisco customers are used to using in those systems.
You're only supporting the AMD CPUs? You're not going to support the Intel CPUs?
This box is AMD CPUs only. We will support the MI series of GPUs in it from, and then, going forward, I think we'll see a broader variety of the vendor CPUs in the AI specific servers. But just point in time where we're at today, it's what makes the most sense for this box. The 885 that we looked at, that is more of an appliance model where you buy a fixed config. This box, you have a lot more flexibility in how you can buy it out as far as the AMD CPUs, the storage, GPUs, and then the Super NICs and the North-South NICs that we have from NVIDIA as well, the Connect X7s. So we are, like I said, announced the box today. We anticipate April timeframe is when we'll begin shipping this box out to our servers, or to our customers, but taking orders today. And we do have it on the show floor if anybody wants to take a walk down and go take a look at it. Key thing is, it is obviously optimized for AI. We have the capability to do some incredible workloads on it, but it does a lot of other things as well. So if I need to scale up into AI, or I need to have a dual function server, this box has the capability to do that. And I can't stress enough the importance of the consistent management. So it plugs into the as a service-based management platform that we have, which you can run on-prem or can be consumed from the cloud of Cisco, whichever is easiest for the customer. But that Intersight platform allows that consistent management of it, so it fits into the overall.
What do you mean with a dual purpose server?
So if I am, maybe I have a traditional large database workload, HPC environment, I also have the ability to run AI workloads on that box. I could transform over the life cycle of that box, or I could, actually have multiple applications running on it if I needed to.
Yeah, I would see that happening for VDI environments, hospitals doing
Right.
a lot of these things. So yeah, that's
At our recent customer advisory board last fall, we heard that loud and clear. We kind of came all in on, hey, here's this 8 GPU server, and they were kind of like, hold off. Most of us are not quite ready for it yet. We need something that, and we have a perception because AI is new and sexy, everybody's talking about it, that it's a thing by itself. But there's never an AI system or an AI application that doesn't have a lot of other traditional servers wrapped around it. So if, especially if if I have an off-the-shelf model that I'm plugging my own data into with retrieval augmented generation, I've got a vector day sitting out there that's on a server somewhere. I've got traditional storage, probably coupled along with the, VAST or DDNs or WEKAs or others of the world that are wrapping that AI-specific storage around it. So it's an ecosystem. And so that's where that dual purpose comes in.
especially the university hospitals doing all the hospital stuff during the day, during the research
Deep
stuff,
research,
doing
yes.
yeah, so
Yes.
pretty,
Or just normal old-fashioned machine learning.
yeah, absolutely.
Right. We don't see it in practice a lot, but one of the unique things about the unified computing system, and I'm sure you're all, very familiar with it, but we have the concept of a service profile. So when we deploy the blade servers, our traditional rack servers out, we go in and we carve out what that server looks like in software. How do I want it to be configured? What BIOS do I want on that box? And in our blade-based system, we've had some customers actually convert that profile day and night, where I can run an application during the day and research during the night, something like that. And so that's something that, we'll be able to do in the future on these boxes as well. Kind of a corner case, but it's out there. But I think, the HPC space is a big place. Some of our traditional database, some of our traditional workloads, very large databases, those type environments. It's going to be a really good fit, and we're going to see our customers grow into it.
And these will be part of the AI pod validated design?
So they're not part of the AI pods today, but that is coming.
When?
So we're not going to start shipping these until April. And so, we anticipate the validated designs, the AI pods, and all of that will be available around that same time frame. So, we're working to get all that together. Okay. Question?
No.
Okay, I saw the mic. As we just kind of wrap up and look at these layers. So we talked about the Cisco Fabric, Hyper Fabric. We didn't go a lot into storage that's there, but we know that's a very big piece. We feel that we've got a full portfolio at that compute layer, whether it is running inferencing on the CPU itself. We have a radiology demo running downstairs in the Intel booth on doing AI inferencing, looking at pneumonia images with just the Intel CPU, no GPU, all the way up to the large 8 GPU systems that we have, and with that C845, fitting in here with the 2 all the way up to 8 GPU systems that are there, and then being able to wrap the solutions, the validated designs, the AI pods, the Hyper Fabric around that. So the NVIDIA NVAIE, the PyTorch framework, whatever the customer needs to run these top layers comes along with that all in one package. Okay. So it is a massive amount of complexity, but it's an exciting place. It's a really, really neat place to be, and we're excited to have the portfolio built out.